Good morning. Welcome back to my stream. It is Tuesday here, but my country had the day off yesterday, so we had a public holiday, so it feels like a Monday. I'm hoping to be able to stream at least 2 more days this week. Let's see how it goes. But right now, let's switch over to my main screen, if I can figure out how. There we go. And then, yes. So what we were working on last time was the text editor, but now we're going to switch back to this, which is this. So our bytecode interpreter is mostly working with what we have. We had this thing here where we can create items of a class, we can create methods in that class and pass in arguments, and then it just runs those arguments. If I say cargo run, like that. I'm surprised I have to build, but I guess I must have changed something before I pushed. So we have the topping method, and then we have the main script, which creates the class, defines the global of the class, and then it creates a closure, which is a function, right? And then creates a method within that and defines it as a, okay. Right, so this closure is this thing here. So that gets pushed into the class. We then get the class and define a global, which is here. And then we call that we look at that property and we see that it must be a method, so we call it with these 2 arguments. And then it just works. right? Because we have this, we add in berries, we now have this as the result, and we then add have this as the result, and then we add cream, and we have this as the result, and we print it. So it all works, which is exciting. But now we're going to have the ability to show what this is. And this, I think we actually have... No, we don't have any examples of this. And of course, this is too common of a word to be able to be used here, right? Just looking to see... Oh, here we go. Right, we can't do this yet because this thing doesn't work. If I do this here, like this is not going to work. Cargo run person, because we don't understand this yet. So that's next. Here it is. Okay, so let's dive in. The reason bound methods need to keep hold of the receiver, right? Because we have the receiver, but we're not using it anywhere, right? Did I comment it out, or I put in an allow dead code? Yeah, because we're not actually using receiver anywhere. So, and now we're going to figure out why we need the receiver. It's so that it can be accessed inside the body of the method. Locks exposes the method's receiver through this expressions. It's time for some new syntax. Lex already treats this as a special token type, so the first step is wiring that token up to the parse table. Okay. So, is that in compiler? I keep forgetting where this ends up. Here we go. So let's just stick it here at the end, along with all the other rules. Rules token type this. And that's going to be a this underscore. So it's just setting the infix. Some compile, oops, because we need an equal sign there. Compiler, this underscore. And then we have to define it. And the parser encounters this in prefix position. Oh, why did I say index? Prefix, there we go. It dispatches to a new parser function, and we're going to add it after variable. Fn this, and it's going to take a, come on, underscore, mut self, and then can assign is going to be ignored right now. And we're just going to call variable and ignore can assign. The underscore at the end of the name of the parser function, because this is a reserved word in C++ and we support compiling with CLOCs in C++. Well, this is not a reserved word in Rust, but I'll go along with it. We'll apply the same implementation technique for this in CLOCs that we used in JLOCs. We'll treat this as lexically scoped local variable whose value gets magically initialized. Compiling it like a local variable means we get a lot of behavior for free. In particular, closures inside a method that reference this will do the right thing and capture the receiver in an up value. When the parser function is called, the this token has just been consumed and is stored as a previous token. We call our existing variable function, which compiles identifier expressions as variable accesses. Okay, but still, I mean, we're still going to have to wire it up somehow. It takes a single Boolean parameter for whether a compiler should look for a following equals operator and parse a setter. You can't assign to this, so we'll pass false to disallow that. The variable function doesn't care that this has its own token type and isn't an identifier. It's happy to treat the lexeme this as if it were a variable name and then look it up using the existing scope resolution machinery. Yeah, okay. Right now that lookup will fail because we never declared a variable whose name is this. It's time to think about where the receiver should live in memory. At least until they get captured by closures, CLOCs stores every local variable on the VM's stack. The compiler keeps track of which slots in the function's stack window are owned by which local variables. If you recall, the compiler sets aside stack slot 0 by declaring a local variable whose name is an empty string. For function calls, that slot ends up holding the function being called. Since the slot has no name, the function body never accesses it. You can guess where this is going. For method calls, we could repurpose that slot to store the receiver. Slot 0 will store the instance. Shrishak, hi, good morning. Slot 0 will store the instance that this is bound to. In order to compile this expression, the compiler simply needs to give the correct name to that local variable. So in init compiler, if we're not doing a function, we can stick the name in. Okay. So our init compiler is called new. And here we have the default. But then we had another initializer, didn't we? Oh, it was for the compile result. That's where we determine it, right? Every time we create a compile result, default means we're doing the script, but then, yeah, we can pass in the chunk type here. Okay. Which means this is where we check. We say is this is what we're doing. We're pushing a name token default, depth sum 0 is captured false. VM user, good morning. Hi. So I think all we need to do is determine what to push here based on whether or not chunk type is a function or a script, right? If it's not type function, oh right, I never added closure to my thing, and now everything is going to break. If it's not type function, then put a this in there. But we don't want that, because script isn't going to have this. That doesn't make any sense. Is that right? We want to do this only for methods. Function declarations don't have a this, and in fact, they must not declare a variable named this. So if you write this expression inside a function declaration, which itself is inside a method, that this correctly resolves to the outer method's receiver. All right, so that means we have a bug somewhere along the lines where we create the different chunk types. Shrishak says, by the way, why are you using t into string, seeing this pattern for the first time? Usually I see cow, stir, azref, etc. I don't know if that's the best way to do it. I mean, we're talking about this line here. But what this allows me to do is anything that can be converted into a string is allowed. Normally, in the past, what I've done is I've had a function, whatever, and then tried to say like name stir, right? And then whenever you call it, you have to say, if you call it with a string, you can say, you know, XYZ foo, and that works. But then if you have like a string, let s string, let's say a string from bar like this, and then I say XYZ s, that's not going to work. I'd have to say as stir. But if I change it to this signature here, right? If I say into string, and I can just say t here, then I can pass this in. Wow. I can't type today. Like this. My God. And I can also say this. And then inside the function, I can just, wherever I use it, I can just say name.into, and it'll convert it into a string. XYZ. Oh, this you're saying here should also work? Well, that's kind of awkward syntax. You're saying that should work if I do this? Like that? Or XYZ S? Maybe. Let's do a quick little test. I'm gonna undo these changes here. There we go. And I still need to fix this thing here. We got to push the right thing. So let's. Do I have a spike already? I do. All right. So, oh, this was a cross-term spike. Okay. So, if I have a function x, right, and it takes stir. I don't know. We can do something with it. Println and the question. Oops. Come on. The question is, if I say main, right, can I call x like this? And it allows me to do that, but if I say let s equal string from XYZ, it complains expected stir. Now you're saying I can do this? No, it didn't like that either. I know I can go as stir. Like that. Okay, and I'll try ampersand s. Okay, so that works. Nope, x. So both of those work. Okay, so then why... So there were some situations where I couldn't. And I can't remember what they were now. Okay, so maybe I'm just misremembering. If I have another example of which something that takes a string like this, can I call x? Yeah, that works too. Maybe I want an own string, so I don't have to use toString. Well, I wasn't using toString, right? I did s.asStir, which is different, right? Okay. Well, If I change this here, whoops, I don't want to do that. I want to do this and then say GD, GI, no, oops. I've forgotten the shortcut to get all the calls to new. And I want to just look for new. Where else do I have into string? Okay, so I have it here, for example, in the disassemble. So, yeah, and this is passing in script to string. Okay, so let me see if I can do it that way here, right? Let's try commenting this out. Do this, and then change this to an str. And then in the chunk, we'd have to do the same thing, right? Let me just try this, and this is simple because I have it here, right? And change that to str. Yeah, see, I thought I had it this way, and it just wasn't being cooperative. So it would be like this. Now what blows up? Oh, I got an extra. Method not found. Why do we have 2 errors? I thought I deleted that. Yeah, okay, so expected stir found struct string. So if I do that, you're saying it should... Okay, that compiles. All right. I'm willing to switch things around if it simplifies stuff. I thought I was having issues with... Well, I guess it also would work, right? This is expecting a stir. If it compiles, it works, Shrishak says. Yep, that's true. But, you know, we could also, by doing the into string, right, like this, then anything that implements toString can be passed in. So I guess that's the one difference, right? If I take a look at, if I create like a struct foo, like this, and I can't pass in, like I say, let f equals foo. I can't pass in f of like this. Can't open file for writing. Right, expected stir sound struct foo. And if I say implement toString for foo, I forget what the function name is. Let's find out. It's just called toString, duh. So fn toString self returns a string, and then just say, I don't know, foo.toString. That should work, right? Right, so this doesn't pass, but if I change this to t is into string, then I can say n.into here. Really? Wait, I thought that would work. Oh, is it because of this? The trait from foo is not implemented for string. No. I thought if I implemented toString, try the into here, you're suggesting? T can't be formatted with the default formatter? Really? But it's stringable. I can try toString here. No. Can I do that? There. Okay. Wow. Shrishak says I might need to derive default, maybe, but this kind of worked around it, but it doesn't have my into string, which is what I was looking for. Right? I wanted the something that implemented something that can be converted into a string. That's what I was looking for. And then this should be able to do into, right? Into string. And then foo can't be. So do I have to implement from? Impl from foo for string. Well, this is distracting us from the thing, but this is more interesting than the other thing. So, what did I do wrong here? Method from has a self declaration, but not in the. Oh, should this be like this? No. Oh, this is the foo. There. And now this works. So I didn't need this part here. Actually, what I could do is this, right? Yeah, so this works. So this goes from toString, and this implements the toString for foo. Right? I could do this, derive debug, and then change this to this format, bang. Right, that all works. It's giving me 2 warnings though when I do this, but I don't see them here. Oh, because I'm in the wrong spike. There. Oh, because I'm not using other example. There we go. Now we have no warnings. Okay. Does this run? Yeah, it prints out everything as expected. Okay. So that was an interesting diversion into this whole thing. So if you want into string for anything, right? Like I have this F, you have to have from for it, so that you can convert it to a string, because the toString is insufficient. That's a shame. Okay, lesson learned. And now I've forgotten where we were. Oh, right, we have to create this. We have to do this, and in order to do this, we need to figure out where we use the chunk type. Because right now, chunk type is set for function. Yeah, add a chunk type parameter. We have chunk type function, and that's all we do. Where are we here? This is return statement checking. So we had up above, I think we added the chunk type. Let's see, type closure. There's type function. Method. That was it. All right, so let's add that in. And then where does it get used? In the method. Okay, fn method. Okay. Yeah, so I put a comment in there for myself to pass in the chunk type. So this is type chunk type method. So this needs a chunk type, C type, chunk type, and we just pass it in here. And then we look for all the other callers of function. It was GI? No, it wasn't GI. I forget what the command was to find all the callers of a. But the easiest way, I think, is just try to compile and watch the failures. All right, so this is function declaration. This is going to take a chunk type function. Oh, that's it? Okay, so that was straightforward. So now if we go to the compile result new, we can see the chunk type. We pass that in here right now, but we want to say if C type is not equal to chunk type function, which doesn't make sense to me, again, because this will be true for scripts as well, which we don't want it to be. Else, I'm going to say local name is going to be, how do we create a default token? How do we create a, do I have a token? Can I say token new? Oh, I can just create it on the fly here. Token T-type is going to be token type this. Lexeme is going to be string from this. And then a line number. Ooh. I guess we don't care what the line number is because we're just... Oh, I see. We hadn't gotten there yet. Okay. Fair enough. We're not passing in the line number here for the token. So I don't know how we're going to handle that. I guess we don't care because it shouldn't ever fail. Line. Oh, I see, yeah. Depth sum 0 is captured false. False. Okay, so that's that. We want to do this only for methods. Function declarations don't have a this, and in fact they must not declare a variable this, so if you write this expression inside a function, yeah, we read that. Okay. Program should print nested instance. To decide what name to give the local slot 0, the compiler needs to know whether it's compiling a function or a method declaration. So we'll add a new case to our function type enum to distinguish methods. When we compile a method, we use that type. Now we can correctly compile references to the special this variable, and the compiler will omit the write opgetLocal instructions to access it. Closures can even capture this and store the receiver and up values. Pretty cool. Except that at runtime, the receiver isn't actually in slot 0. The interpreter isn't holding up its end of the bargain yet. Here's the fix. Okay, so we're going to go to the VM and see what's going on there. So in bound method, oh, this is in call value. Right here. We're going to stick. Right, so this is this situation here where we grab the stack top and then we can access this and set it to, oops, the bound receiver. I call it method. So method receiver. Can I do that? That's probably private field, right? Yeah. And then it's also saying mismatched types, expected struct RC. Oh, okay. So we can just say RC new. Well, let's see. We should probably, if it's a receiver, let's take a look at method. Maybe this should be in an RC so we can clone a reference to it. Nope. Right? And that way anybody who accesses it has the same. Oh, I see. Oh, okay. RC new. Yep. And then this should be RC clone. Oh, actually, we could just pass it back, right? We can just say pub fun get receiver self, and it just returned an RC to the value. King 440, thank you for the follow. RC clone self receiver, like that, and then here we just say method get receiver. Will that work? And it doesn't compile. Oh, because we need an RC ref cell. Oh, that's a problem. Right, because it has to be an RC ref cell value. And we don't... So how do we get that value in there if it's already in an RC? We can't assign to it, right? We can't assign to this. So it should be okay if we clone it out. Right? Oops. I wanted to actually go in bound method and change all this back. So I think if we just clone it out, that should do the trick. Self receiver.clone, and then we can put it in. We can put it in here in RC new ref cell new get receiver. Stop it. King says, enjoying Rust? Yes, I very much am enjoying Rust. It's a lot of fun. There's too many L's in the cell there. Okay. When the method is called, the top of the stack contains all the arguments, and then just under those is the closure of the called method. That's where slot 0 in the new call frame will be. This line of code inserts the receiver into that slot. For example, given a method call like this, we calculate the slot to store the receiver like so. Okay, the negative arcout skips past the arguments, and -1 adjusts for the fact that stack top points just past the end, past the last used stack slot. All right, so this should work now, right? Except it doesn't do anything. We had another function that used this, right? Yeah, so cargo run person. It panicked. So that's good news. On line 95. No chunk. Did I overwrite the wrong thing? What is this saying here? We're trying to call... Oh. Maybe we just haven't finished it yet. Sometimes he does that. You know, halfway through you say, okay, we're done with this part, but then there's more work to do, so it doesn't really work. But I would have thought this would have worked at this point. Here's function say name, and I thought we would see a right, this is a bound method. And now we're trying to call a person instance instead of... Oh yeah, so yeah, this is the this, but then we need to okay, let's take a look at this code again. So we grab the bound method, we set argument 0, and then we call. Yeah, so that's the same order I'm doing things. Let's get rid of this stuff. Let's print this. Println before stack looks like this. Self stack, and then after stack. Right? And then if we take a look at what that, we should see it when we try to call. Right, so the before stack looks like this giant mess. How am I supposed to decode that? And then after stack looks like this. So where is the the this parameter. I see a value here, this. Maybe I print out the receiver as well. I should be able to do that more than once, right? Method receiver, get receiver. Yeah. Here's the receiver. Instance of a class, a person, ref cell, senior. So it's the whole thing. Yeah, so that's the person instance that gets pushed onto the stack. Huh. And then, but then when we call, we should be calling the script of sayname. So it looks like we're overwriting sayname with the person instance instead of putting it in quote slot 0. Unless, if I look at line 95, right? So this is we're trying to look at the current frame's closure and get the chunk. And we push the call frame right here. So it could be that we're trying to access it beforehand. That doesn't make sense. Here's arity. We're checking the argument count, checking to make sure we don't have a stack overflow. We push the closure on. Oh, yeah, this is where we just pushed, we just changed. Right, we just pushed that stack top minus arg count minus 1. We changed it to the receiver. So it's no longer a closure. Or a bound method. And it in fact is an instance of the class. But that's the same as here, right? This is the topping call frame. Bound receiver. And then just under those is the closure of the called method. Just under the arguments. And that's where slot 0 in the new call frame will be. This line of code inserts the receiver into that slot. Right, so 0 is fn topping, 1 is berries, and 2 is cream in this instance here. So this is doing the same thing. It's saying, okay, well, we'll put that there. But we need to be able to our VM now supports users correctly using this, but we also need to make sure it properly handles users misusing this. Lock sets it's a compile error for this expression to appear outside the body of a method. These two wrong uses should be caught by the compiler. That's true. But we still have this issue here, because if we're restoring the receiver, this fn topping gets replaced with the instance variable. And in that case, how do we know? Yeah, something's fishy here, right? Unless I'm forgetting to do... No, I'm not forgetting, because this is all correct here. I'm I'm very lost. All right, so let's figure this out. If we look at the compiler, when we create a new this, right, we either create with an empty slot, or we have the this slot on there, and that's position 0. Okay, when we here's function, and then we also have method right here. Should this be doing an extra? So here's the begin scope. No, I mean this has 3, right? 0, 1, 2, and 3 is the stack top, which has nothing on it. So we really are replacing this, but then I guess the way they have stuff is you just pass in the method that you're trying to call, and then we don't care that it's on the stack, because that was a change I made, right? To not, instead of on the stack, instead of putting the closure directly in the call frame, we just index into the VM stack, and that's no longer the case. So I think that's what I broke when I decided to do it that way. They put the function here, and then they replaced the function with the instance of this, and that gets stored there. And so since the closure got replaced, we no longer have it available to us in the call frame, and we can't get the chunk for it anymore. So that means we have to do some refactoring. Right? Because we're going to push this, and we're saying the closure is supposed to be where it's supposed to be, but it's not. Can I refactor this without too much pain and anguish? Let's find out. So we're going to start by changing this to be an RC of a closure. All right, and then we have to find every place that we use this. All right, so here's the first one where we call get up value. So we're going to get, we have the closure. We don't have to do the stack position bar or deref anymore because we actually have the closure directly. So that means, can we just do self current frame closure? And get rid of this position thing. Oh, it's an RC. So this is where I have to do deref. Nope, doesn't like that either. Expected struct closure found enum value. Oh, because it's a closure. Oh, so if it's just a closure directly, I can do that. Yes. Okay. So then the same thing with setup value. Yep. Okay, and then chunk, we can just say we have the closure directly, so we don't have to do anything else other than saying self current frame closure get chunk. Okay, and then here we're going to actually pass in the closure, right? RC clone closure. That puts the closure there. And what else is broken? Okay, so this is the same thing with a runtime error. Current frame closure. And now we're going to find out about what borrow checking problems we have. Oh, let's just say let. Move occurs. I don't want to move it, right? But I can say here, I can say self get current chunk, like that, right? Oops. Really? Oh, did I thought I had a, what did I call it? Chunk. Oh, it's just called chunk. I was mixing up current frame and chunk. So we just say self chunk dot closure. Nope. Oh, wait a minute. Yeah, so that's right. I want a current frame closure. Okay. I'm going nuts here. And then get line. What was this before I started changing everything? Now I have to go back here. I can just do a git diff and find it. Closure stack name. So whatever the closure is has a stack name, and then I have a line. Closure.getLine is what. Oh, that's the new one. Closure get chunk get line. Okay, so we can just call chunk get line. Okay. Closure, we can call chunk like this, get line. There. Okay, now we got 3 warnings. Oh, right. I was getting hung up on the changing stuff. So we can just say self current frame closure dot get up value offset. Can I do that without the deref? Yes. And I can do the same thing here. Closure modify offset value. Wow, okay, that simplifies things a bit. And then we're not using deref. Okay, there we go. So let's see, does this work? Cargo run person. Undefined variable this. Because it's getting global. Oh, okay, so we're down to the next bug in my wonderful code here, is that I'm not, when I create the variable, oh, not in the VM, in the compiler. When I add this as a token, it's not actually putting it in, making it findable for whatever reason. So what's causing that issue? Let's get rid of those print statements. Yeah, okay, so that fixes that. Yeah, undefined variable this. Okay, but now we're not getting this. Oh, index out of bounds. Len is 7, but the index is 33. That's interesting. That's in chunk. Oh. Right, that was the other thing, is when we exit a function, we're supposed to set the IP to point to... That was the other thing I kind of cheated on, isn't it? That's pointing to the ref cell. That's pointing to the chunks IP. But that should be okay, because we're popping the call frame. I wonder if it's related to the fact that we're not finding this anywhere. So yeah, I'm calling this, right, for variable. Let's just verify that in our compiler that this is being called. Println found this when we compile. Yeah, found of this. But it's doing a get global this instead of, because it's not finding it here. Slot 0 will store the instance that this is bound to. In order to compile this expression, the compiler simply needs to give the correct name to that local variable. Apparently it needs to be more than just that. How does the compiler look up? That was part of the other thing we had to mess around with, is figuring out how to look up variables. And I'm just scanning through the code here. Here's variable. Look up named variable. So we go resolve local. And this should resolve as local with a this. So I think what's happening, cannot resolve local with its own initializer. Right, we're looking here and we're looking to see if we can find it local. We're calling find variable. Self locals borrow, iter, rev, enumerate. Okay, so here's where we're trying to look up this and it's not finding it. So let's find out what's going on, because that self local should have the this in there. Println e v. Of course, local can't be formatted with the default formatter. Can I debug it out? There we go. Let's just add debug to this. Token doesn't implement debug? Why not? There. Okay. So now let's run this, cargo person, and we can watch it finding variables and things. Yeah. We're not doing it right then, if we're not actually pushing a this. Okay, so what do we got here in the compiler? Let's print then creating chunk of type C type. Still didn't like it. Oh, debug. Okay. And what do we got? Creating chunk of type method. right? So it's a method. This says founded this, and then it looks and it can't find it. So let's take another look here. If ctype is not equal to function, then we're adding a token. Println. Oh. Compile results is this. And we can't do that. Bug. Oh, up value data. Okay, let's try this. Yeah. Okay, what did I do wrong? Because I could have sworn I pushed. If ctype is not equal to chunk type function. Oh, I have it backwards. All this time I had it back. Let's do it in the same order they have it here. Get rid of this println. Get rid of this. What else am I doing? I can get rid of. All right, I'll try them one more time. Okay, this time it has a this, and now it actually has a get local. It still doesn't work. We're still panicking on the pop. So get undefined property name. Oops. Huh, it shouldn't be name. That's weird. Oh, we're not looking at this function here, right? We're looking at the person thing. Which is where? Cat person. This dot name. So we say var Jane equals person, Jane dot name equals Jane. Set property name to Jane. Pop. And then set method is equal to say name, right? And then we're going to call say name. We get the person instance, and then we look for the name property, and it doesn't exist. Oh, maybe this isn't supposed to work. Oh, it should, though. Right? Because Jane is a new instance of person. We get we have to get the actual, the same exact person instance that we have here. So that's not working. Kronborg, hello. Thanks for stopping by. So this panic is probably related to the issue. I always have a bug in my error reporting thing here. Line 400. I forgot to put a format around it. And we'll bet the other one. that one already has it. Okay. So if I say cargo run person now it says undefined property name. Okay. All right. So this instance should be the receiver, and that receiver should have a name property set on it. So this person instance actually should be Jane, not person instance. Is this a situation where we have... Yeah, these are the fields. We have a ref cell, a hash map. So this is the instance that goes on the stack, right? It has a reference to the class it is, and it has a list of all the fields in it. We're definitely doing a set field, which is the set property of name. It's the name Jane. Define global get global method. We call the method of say name. And this is the person instance that we're supposed to be, we replace say name with that receiver of Jane. Let's watch that happen actually in VM. Here's where we're putting the new receiver. So can we print out the receiver here? Frontline. And take a look at what the receiver looks like at that point in time. It has a value name with a string Jane. So when we say get property, is the get property going on this? Where's this additional person instance coming from? And is it going? It's trying to get it off of this instead of slot zero's this. So this is setting correctly, right? So that part's correct. When we get to this, oh no, that's right. So get local is getting the this and pushing it on the stack, and then we want to get the property of that. So let's take a look at the get property opcode. Yeah, that's peeking at the top and looking. And we're getting all the way to here. Self bind method instance unwrap get class field name. What does bind method do? It's creating a new bound method. Kronberg says the warning and error numbers in the bottom of Vim seems helpful. How'd you get those? Okay, so that I use. Is it here? Nope. Somewhere along the lines, I have the info for that. Here. except not that far down. So this is what I use. I clone this into my workspace, and then right now it's set up so if when I hit Control D, it saves everything that's being edited and then runs cargo check and then generates a quick fix list. So if I put an error in there, right, it'll do that, and it'll show me the error, and then it'll jump the cursor right to the error. If there's more than one error, right, now I have 7 errors, right, so I can hit next, 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 and it'll show me all the errors. But basically just this thing here. It's pretty handy. It makes the edit, compile, debug cycle go a little bit faster. I guess what I'm worried about is that this instance is not going to be the same instance that maybe we're creating a brand new instance on the stack instead of, right? Maybe this instance is not the same as this one, and that's why this name doesn't exist. So when we call get local, let's take a look at that one, get local. We are cloning what's on the stack. So it should be the same thing. Let's see if I can print it out. Self, stack, last, unwrap. Okay, so that's going to generate a lot of output. Oh, I thought it would generate more output. But here, no. So it is, while it is cloning it, it's cloning it, but still has a property on the fields. And then when we say get property name, it's saying undefined property name. Yeah, no problem, Kronberg. It's it is very handy. So let's figure this out. So get property is failing. Let's take a look at get property, and we can debug that one step at a time. And just get rid of some of these extra prints. Okay, so get property. So we can say the instance get prop instance is equal to instance. And let's run that. Yep, it has the name. Okay. Here it is. So we definitely get to that point here. Unable to get class name from value. So let's see. Of field name. Unable to get class name from table? Right, okay, let's print that out. Wait a minute. I don't see the get prop name instance. Okay, there it is. Get prop say name instance. So we're definitely finding it. And then we call get field, and that's what's failing. Instance as ref unwrap get field name. So if I look at get field, and then we're hitting this undefined property field name. So if I say println getting field name string, from this. Self fields. Oh, name has moved. Name. Oh, I can't clone it. All right, let's try changing this back to what we found last time, as this works. Name to string. And I should be able to just say name here. And then, of course, something else failed. Oh no, that all works. Okay, good. So let's print this out. Getting field name from ref cell name, undefined property name. Okay, so we're getting closer. It's definitely there. It's just not able to find it. Nope. We're looking at instance. We're looking up name, converting it to a string, and then looking in the hash map for it. And for some reason, it's not finding it. Println. Name is debug, and we'll just say self fields borrow get name to string. Fields. There we go. Okay. And what does this show? Name is some stir Jane. What's going wrong here? We'll shadow it here. Name is this, and then we'll just say name here, and then we'll do the same thing here. Okay. What the hell's going wrong? Source VM. Get property. Oh, so this is working. We're getting the value. Duh. I'm digging into the wrong problem. Right? I bet you it's the bind method that's failing. I have it right here. Let some value. Oh. Print value. There we go. Jane. So Jane is getting pushed on there, which is that right? Is that what's supposed to be pushed on there? Push value clone. Maybe, yeah, print out debug so I can actually see what it is. It's a string. So we're printing string Jane. And then we're calling bind method instance unwrap get class of field name. So this is what's failing. We get the class of the instance, which in this case is person, and we get the field name, which doesn't exist on the class itself. So maybe this is what's failing here. Self peak 0 borrow clone is the value. That's what we just pushed on the stack here. Okay. I bet you we're not even getting in here, right? Oh, because we're trying to call a method on the field name. Okay, so that doesn't seem right. Did I mess something up here with get property? Why are we calling bind method? Oh, maybe this is supposed to return if it's a field, we return here. Oh, that would be an interesting bug. Here's bind method. Yeah, break. So at this point we're supposed to break. We're not supposed to keep barreling on through. That makes more sense. So if it's a field, it's an instance. It's a field on an instance, then we push it. If it isn't, then we look to try to bind the method. That makes a lot more sense. And what else did I mess up? Oh, I guess we don't break out of these things. We can say else, though. All right, let's try this. And there it is. So print out Jane. Okay, all of that because I've left off the ability to break early. Oops. Okay, that's working. Oh, let's get rid of these things. That's in the compiler. Right here. Oh. I don't want that. I don't want that. And that I do want. Okay. Okay, and this should still work. Good. Okay, so we have this working. That's good news. So this is section 28.3.0. Git add source. Git commit -m section 28.3.0. This. Okay. Whew. That took an hour and a half just to do this. That was frustrating. All right. So these two wrong uses should be caught by the compiler. And if I say cargo run right now, and I just say print this, it says undefined variable this. So it does say that, right? And, oh, and I can try this one. Fun not method print this not method undefined variable this. So it is catching them, but it's not catching them in the compiler, right? This should have caught the error here. So how does the compiler know if it's inside a method? The obvious answer is to look at the function type of the current compiler. We did just add an enum case there to treat methods specially. However, that wouldn't correctly handle code like the earlier example where you're inside a function which is itself nested inside a method. We could try to resolve this and then report an error if it wasn't found in any of the surrounding lexical scopes. That would work, but would require us to shuffle around a bunch of code, since right now code for resolving a variable implicitly considers it a global access if no declaration is found. In the next chapter, we will need information about nearest enclosing class. If we had that, we could use it here to determine if we are inside a method. So we may as well make our future selves' lives a little easier and put that machinery in place now. All right, so this is in our compiler, probably in this compile result. We're going to say what the current class is. Class compiler. Oh God, we're going to have this issue. We're going to have nested class, and we have to handle nested classes, which means maybe compile results. But that's enclosing, right? We already have it as enclosing. Right now we only store a pointer to class compiler for the enclosing class if any. Nesting a class declaration inside a method in some other class is an uncommon thing to do, but Lock supports it. Just like the compiler struct, this means class compiler forms a linked list from the current innermost class being compiled out through all of the enclosing classes. All right, so class compiler, I guess we're going to have to create that. Oops, I forgot the thing here. Struct class compiler, and that's going to have an enclosing, which is going to be a ref cell to an RC class compiler. Oh, ref cell option, right? Because if it's null, it's null. I guess current class. Oh no, that's true. Option. We're not always in a current class. This should work as long as I put a default here. Yeah. And the warnings, we have 3 warnings, but that's because we're not using current class. Okay. Right now we store only a pointer to the current class. Okay. If we aren't inside any class declaration at all, the module variable current class is null. So that's the option, where the option comes from. It's either going to be none or some RC. When the compiler begins compiling class, it pushes a new class compiler onto that implicit linked stack. So fn class declaration. So in between defined variable and named variable, we're going to say self dot So this is inside the compiler, and this is going to result ref cell thingy. So we can say result borrow mute, or borrow, right? We're just borrowing it, and then we're going to say current class replace with a new class, class compiler. I'll say new, and then we'll just create a new for it. Which is just going to return self and closing ref cell new of none. Right? And then we actually need to assign the enclosing for the next one. So previous is now the one that the new one needs to point to. Self result borrow current class dot borrow mute dot enclosing equals prev. Right? And that way it's pointing to the previous one. The current one that we just made a new on, is now pointing, has its enclosing of the previous one. Rough cell, new, prev. I think that's the correct order to do things in. And then after the pop, we have to reset it. Self result borrow current class replace prev. Then we put the old one back and throw out that one. Should we? I wonder if I don't know how well Rust keeps track of things. If I do this, enclosing equals ref replace. No. I'm trying to think, do I need to set this to none or not? I don't know if this is even going to work. Oh, some. Expected struct RC. And then this doesn't work. Unknown field, current class. Current class doesn't have an enclosing? It's right here. Oh, Talk a bit. It's going well. I'm about to wrap things up. As soon as I can get this part working, and then I'll work on instance initializers tomorrow. But I just need to get this push pop business going. How's it going with you? How was your weekend? All right, so we can't. Current class has a ref. It's a ref cell option, right? So so current class borrow mute should get us the option of class compiler. Oh, weekend was nice, excellent. Yeah, I know a lot of people in Europe get a pseudo 3-day weekend when people in the US take the 3-day weekend. I know a lot of my coworkers do that. And then there's the Jubilee coming up this Thursday, Friday. So a lot of my UK coworkers and family are taking the whole week off. So anyway. Yeah, so what I want to do is have the this new compiler have the enclosing one be the current class. Should I create it outside and then set it? Oops. Let new class is equal to class compiler new class dot enclosing dot borrow Oh. Oh, but no, it's saying enclosing is an unknown field. New class. Enclosing. Replace with... No, then we're going to get a loop. You had to get some tea? You didn't miss anything. I'm still struggling to get this. So what I want is the current class here. But take a look here. So I have this current class, which is going to take an option to a class compiler. When we create a new class, we're going to put a new current class here, and then have the old one point to the class compiler. And I'm struggling figuring out, oops, how to make that happen. This line here is creating a new class compiler and replacing the old one and giving back the previous one. So I should be able to take the previous one now and make that the enclosing of the new one. And I'm getting stuck on the fact that it doesn't know what enclosing is, even though it's right here. And if I try to compile this, it's telling me enclosing is an unknown field. It's a ref mute option. So oh, you simply never added classes. Okay. Just control flow functions and loops. Yeah, that's a good way to solve it. Just don't need it. All right. I think I'm struggling too much at this point, so I'm going to leave this bit out for now and just say to do replace current class with a new one and point enclosing back to the new one, old one, previous one, and then down here replace the new class with the previous one. And we're going to leave things like that for today's stream. 4 warnings, that's probably because we're not using any of that stuff. That's fine. I'm going to commit these changes part way through section 28.3.1. There. And then we'll fix it tomorrow when I have more brain power, because I've run out of brain power. Oh, what's it? No verify? There. Git push. Done. Okay. Yeah, actually, one of the things I want to do is play around with, after doing all of this, I want to actually write an interpreter for, I'm thinking basic. So if I can write a basic interpreter using what I've learned from this, I think that would be a good proof of accomplishment. Basic is simple enough that I could just do that. All right, anyway. That's brilliant. Yes, I'm brilliant. Thank you. Very few people tell me that, especially my wife, for some reason. Doesn't want to tell me I'm brilliant. All right, that's that. I'm going to sign off for the day, and I'm going to tomorrow we're going to work on fixing this, getting this working, and then doing instance initializers. So we'll see how that goes. So that's that. I enjoyed the stream. I hope everybody who watched did as well. Those of you here and on YouTube. And I will see you tomorrow. Take care.